Okay, so if you have a general quadratic equation, what are the two solutions? What's the formula for it?
X equals.
Come on, y'all. What are the solutions to a quadratic equation?
Solutions.
What you mean solution?
It's an equation. X equals an equation. X equals.
Yeah, it's Monday, but quadratic equation. What are the solutions?
AC is when you put the AC together and add it. B plus.
Oh, the quadratic
Oh,
formula?
the quadratic formula.
Yes, the quadratic formula
Oh.
is the solutions to a quadratic equation.
Like x equals 0, x equals...
No.
Oh, you should have just said quadratic formula.
I did. I said, what are the solutions to quadratic equations?
I was like,
It's the
am I
quadratic
supposed to know
formula.
some answers?
Okay. All right. So you have two answers. You've got negative b plus the square root of b squared minus 4ac over 2a. And you've got, I'll call that x1. x2 is the opposite of b minus the square root of b squared minus 4ac all over 2a. Okay? Well, when you add those two together, so what would x1 plus x2 be? Well, it would be negative b plus the square root of b squared minus 4ac all over 2a plus negative b minus the square root of b squared minus 4ac all over 2a.
Oh, I see.
Well, okay, they already have a common denominator of 2a. So on the top, you're just going to have negative b plus the square root of b squared minus 4ac minus b minus the square root of b squared minus 4ac. Well, plus that minus that goes away. Minus b is minus 2b over 2a. It is negative b over a. So if you have a quadratic equation, this is the two solutions, but the sum of the solutions is negative b over a. Okay? Now what about the product of the two solutions?
You said this was the
That would be negative b plus the square root of b squared minus 4ac all over 2a times negative b minus the square root of b squared minus 4ac all over 2a. Right? Okay, well, on the bottom, we've got 4a squared. On the top, we've got two binomials. So we have to FOIL. Negative b times negative b is b squared. Negative b times minus the square root is plus b square root of b squared minus 4ac. That times that is minus b square root of b squared minus 4ac. That times that is minus, what's the square root of b squared minus 4ac times the square root of b squared minus 4ac? b squared minus 4ac. So, plus that minus that goes away. So on the top we've got b squared minus b squared plus 4ac all over 4a squared. That goes away. We are now left with 4 AC over 4A squared. 4's cancel, and A cancels with A squared and leaves A. So that is C over A. So what you have is, here you go. If you have the two solutions to a quadratic equation, the sum of solutions is negative B over A. The product is what? C over A. Okay? Now, all this does is it kind of gives you a shortcut for some things you already know. Okay? So let me do some examples. So what if I said write a quadratic equation that has roots 3 over 4 and negative 12 over 5. Okay. Well, what is their sum? You need a common denominator of 20. So you'd multiply that by 5 over 5, and you'd get 15 over 20. Minus, multiply that by 4, and you'd get 4 over 4, and you'd get 48 over 20.
What did you get to do? Get 48
12 over 5. Okay. You subtract those or add them, whichever you think of it. It is negative 33 over 20. So that has to equal negative B over A. Well, maybe. B is 33 and A is 20, or B is 66 and A is 40. Or B is 99, A is 60. Doesn't say B is 33 and A is 20. It says their ratio is 33 over 20.
So you cross multiply, right?
No. It's you could multiply by 2 over 2. And you'd get B is 66, A is 40. Multiply by 3 over 3. No, I haven't cross multiplied. Okay?
So it could be like any two numbers as long
That
as the ratio.
reduced to that.
Oh.
Okay?
Oh, you got a common denominator. I'm so
Yes.
sorry.
Okay, now let's do the product. Now, if the product has 20 in the denominator, then we're okay. This would be 33, 20, and the other one. Okay, but the product is 3/4 times negative 12 over 5. So 4 goes into there 3 times. So that's negative 9 over 5. Okay? But it doesn't mean it's 9 over 5. It could also be 18 over 10, be 27 over 15, 36 over 20. Okay? You need these to have the same denominator. So we're going to say equals negative 36 over 20, and that is C over A. So let's see if this works. Would that work if A is 20, B is 33, and C is negative 36? B over A would be, or negative B over A would be negative 33 over 20, right? C over A, 4 goes into both of those, it'd be negative 9 over 5. So that works. So your equation is 20x squared plus 33x minus 36 equals 0. Now, personally, I don't like this method. Okay? To me, it's easier. Okay, if you know you have x equals 3/4 and x equals negative 12/5. Okay, so just remind me I haven't put roll in. So if you get that, so if x equals 3/4 was a 0, what was the factor that gave you that? Right? Because if you said x minus 3/4 equals 0, then you'd have x equals 3/4, right? But you can't have a fraction. So what we could do is multiply everything by 4. Because, or here's a better way to think about it. If you got x equals 3/4, the step right before that was 4x equals 3. And the step right before that was 4x minus 3 equals 0. Right? So the factor is 4x minus 3. Likewise, if you had x equals negative 12/5, the step before that said 5x equals negative 12. And the step before that was 5x plus 12. If you FOIL this, you get that. That's the method I prefer. But you could check yourself. You could find the sum and see if that's negative b over a. Find the product and see if that's c over a. I prefer to use it as a way to check. I prefer to do it this way, but check with the sum and product.
So do you mind on the homework if we...
I do not care. Whichever way you want to do it. Ever how you get to the answer is fine with me. Okay. Let's do another one. Now, here's one where it is easier to do it the sum and product way when you have an imaginary root. Okay? So what if I said write an equation with roots 7 minus 3i and 7 plus 3i. Okay? Well, what is the sum? 7 minus 3i plus 7 plus 3i is 14. Right? So negative b over a has to equal 14. So we could have 14 over 1. We could have 28 over 2. One of them being b being negative. Okay, then the product is 7 minus 3i, 7 plus 3i. That's 49 plus 21i minus 21i minus 9i squared. Those cancel. And that is 49 plus 9, which is 58. So that means C over A has to be 58. Well, the easiest, since both of these were not fractions, would be to get A equals 1. Right? And if A is 1, what does B have to be? B is negative 14. And what is C? 58. And there's your equation. X squared minus 14x plus 58. Negative 1. Okay? Now, the other way to have done that would be if you had x equals 7 minus 3i and x equals 7 plus 3i, then the factor would be x minus 7 plus 3i equals 0, and x minus 7 minus 3i equals 0, right? So you would have x minus 7 plus 3i times x minus 7 minus 3i. And when you FOIL that out, you get that. Okay? So, but when it's imaginary, I think the sum and product method is easier. Because there's like 3 steps in here that I skipped. Okay? Okay, solve. And then check using the sum and product of roots. Okay, so we solved. We can either factor or do the quadratic formula. Let's do the quadratic formula to make sure y'all really do remember it. Okay, it's opposite of b, 7, plus or minus the square root of b squared, 49, minus 4 times a times c, all over 2a. So that is 7 plus or minus the square root of, that's 24. 49 minus 24 is 25. Square root of 25 is 5. So we got 2 answers. 7 plus 5, 12 over 4, which is 3. 7 minus 5, negative, or 2. 7 minus 5 is 2. 2 over 4 is 1/2. Okay? So, what is the sum? It is 3 plus 1/2, which is 6 halves plus 1/2, which is 7 halves. And that does equal the opposite of b over a, the opposite of negative 7 over 2. And then the product is 3 over 2, which is c over a. Okay? And it actually makes sense if you had 2 zeros. So let's say you had, I'll call them R1 and R2 as your 2 roots, right? Well, your factors would be x minus R1 and x minus R2, right? The only time it wouldn't be that is if it were a fraction. And if it were a fraction, you would multiply through by the denominator, and that happens to be what a is. Because, like, if there were a 3 here, you're going to get 3x squared. So whatever you would multiply by would be your a. Okay? So this is for a equals 1. But if you had a denominator, you'd multiply through it. So what if we FOILed this out? X times x is x squared. That's minus R2x minus R1x plus R1, R2. Well, if you factor out an x, you've got minus R1 plus R2x plus R1, R2. Right? If you factor out a minus, you've got R2x plus R1x. Well, that's R1 plus R2x. So, there you have it. The sum, negative sum over 1. Product is c over a. Right? The only way that would be different is if there was an A here. And you would have that over A and that over A. It would be the exact same thing. Okay? All right. Well, that's why I have it. So you can. All right. So, that's really it. Okay? So the sum is opposite of B over A, and the product is C over A. You can use that to either solve the equation or to check your answer. Okay? All right, so your homework.
This is a breeze from last chapter.
Yes. That's why we saved it for the end.
Oh, that was so nice.
All right. Homework is page 363, 19, 22, 26, 27, 30, 32, 33, 35, 36, 39, 40, 41, 43.
I'm running out of
13
paper
problems.
space.
I know, it looks like a lot, but it's just 13 problems.
Oh.
Oh.
Yeah, it's only 13 problems.
I'm like, I don't think this is.
All right, that's it.
I'm
Now, this homework is not due until Wednesday. We are doing MAPS test tomorrow.